So let us consider the third problem. I think first problem we have discussed in the last class. Now we consider the third problem, so you can understand easily. A standard insecticide is used to control a particular insect pest in soybeans. The probability that with which this insecticide eliminates the insect from an individual plant infested with the insect is 0.7. A new insecticide is developed which is known not to decrease the probability of insect elimination. It is decided to determine if the new insecticide performs better than the standard. An experiment is to be conducted in which 500 randomly selected plants known to be infested with the insect are sprayed with new insecticide. After a fixed period of time, the plant for which the new insecticide eliminates the insect will be counted. The experiment will reject the null hypothesis that the insecticide has no effect if the insecticide eliminates the insect in 375 or more plants. Okay. First one, state symbolically that null and alternative hypothesis, defining all symbols in words. What is the alpha level of the proposed test? If in fact the success rate of the insecticide is 0.8, what is the power of the test? When the experiment was actually carried out, it was found that new insecticide eliminates insect in 395 plants. Find the p-value of the test. So this is a typical hypothesis testing problem. So several informations are given. So what are the informations given? Yeah, look at this. There are two possibilities because for the random number of observations, 500 observations. What is that? The new treatment will eliminate the insects. That is a success. That can be considered a success. If the new treatment not eliminates, that is a failure. Okay. So we can consider as number of plants in which the insects are removed by this particular new type of insecticide. Okay, so we are having 500 number of plants. Okay, and I will show you that we have sprayed the new treatment, new medicine, pesticide, and suppose we have sprayed some consider this plantation. Look at this plantation, and we put some pesticide, applied pesticide to this plantation, and suppose there are 500 number of plants in this plantation. Okay, we are applying the particular medicine, new medicine, and what are the informations given? So 500 number of randomly selected plants are considered and sprayed the new insecticide, and it is found that what is the observations? Yeah, we have to check whether this new insecticide is effective or not. We will consider the experiment will be reject the null hypothesis that the insect no effect. We are assuming that the new insecticide has no effect. So that is the null hypothesis. And what is the alternative? We will say that this new insecticide will be effective only if it will eliminate, if eliminates insects in 375 or more plants. So what is the rejection region? Yeah, number of plants in which the insecticides are eliminated is greater than or equal to 375. So that is the rejection region. So we can consider as a binomial distribution for the that number of plants in which the insecticides are eliminated. Okay, so we have to check whether what is that mu is equal to 7. That means this is the what is that assume or the value mean value taken. Yeah, it is given. Individual plant within the probability that which this insecticide eliminates the insect from the individual plant infested with the insect is 0.7. So this is the standard control value. Okay, this is the standard control value, and we have to check whether our new medicine or new insecticide is more effective than the existing standard control. So we will check the assumption that is, what is the assumption? Mu is equal to 0.07 against mu greater than mu greater than. If the new insecticide is effective, then the rate will be much greater than 0.07. Okay. So how can we compute the parameters? What are the parameters we are discussing in hypothesis testing? One is probability of type 1 error, second one is probability of type 2 error, third one is power. So what is the alpha value? That is probability of type 1 error, that is probability of x greater than, this is a rejection region we have discussed, x greater than or equals 375. So that is the rejection region. Thereby we can compute the, what is that, the probability. So probability of x is the number of plants in which the insects are removed, okay, using the new insecticide. Okay, probability of x greater than 375 given that null hypothesis true, that means not effective. So we can standardize like this: x minus np. For the binomial distribution the mean is np, so we can put like this: x minus np divided by what is root npq. In the case of binomial distribution, the variance is npq, so the standard deviation is root npq. That greater than or equal to 375. We can do same probability action in two sides. So 375 minus np by root npq under null hypothesis. So this is standard normal. So set this a simplified value of this one is 2.4398. So from the standard normal table you can see that probability of z greater than 2.4398 is 0.073. We have discussed how to find out the probability using standard normal table. So you can check that this result is correct or not. Okay, so we have obtained the probability of type 1 error. Now we have to find out the probability of type 2 error, or we have to find out the probability of, or we have to find out the power. So what is power? Power is, that probability of rejecting null hypothesis when alternative hypothesis is true. Since alternative hypothesis is mu greater than 0.8, we can take any one of the value for the numerical calculation. So we take the what is that value of p as, or mu as, is proportion. Okay, mu as 0.8 instead of 0.7. A value greater than 0.7 is 0.8. So we take it as 0.8. So what will be the power? We can apply similar action. Instead of 0.7 we can use 0.8, and thereby we will get probability of z greater than 375 minus np by root of npq. Okay, so that is probability of z greater than minus 2.8. So that is actually 0.9975. Okay, you can find out this value using the table. Okay, so power is this one. So what will be the probability of type 2 error? 1 minus power. Okay, so that is, or otherwise we can compute like this. This is the, or either you can compute the probability of type 2 error as 1 minus power, that is 1 minus 0.9974, that will be very close to 0, or we can compute like this. Okay, probability of rejecting H naught when this is not correct, this is some error is there. You don't write this one, you can write like up to this after verification. Okay, you have to verify these values. So what is probability of type 2 error? 1 minus 0.9974. What is the value? Point 0.0076. Okay, 0.0076. So what they are asking? Yeah, the okay, power of the test we have obtained, alpha is obtained. Yeah, here they are considering 3975. So actually, if it is observed that it eliminated 395 plants. So what is the p-value? Yeah, that is the p-value. Okay, in the last D section, it is the p-value. P is the probability of rejection when we are seeing the actual value. That is, actual value is 395. So we can this is the p-value, not type 2 error. That was the reason we are confused with that. Okay, anyway, this is the p-value. That means we are actually observed that x greater than 395. So that is probably set greater than, we can standardize like this: 395 minus 500 into under the null hypothesis, that is 0.7. So that is actually probably set greater than 4.39, that is very close to 0. Okay, so that is, if the p-value is much smaller than if the p-value is much smaller than 0.05, because we have considered the significance as 0.05. Moreover, it is one-sided test. If it was a two-sided test, we can take the significance range for the p-value as 0.025. So in this case, it is a one-sided, so we can compare with 0.05. So since this value is much smaller than 0.05, we have to reject the null hypothesis. What is the null hypothesis? The insecticide is not effective. So we will conclude that the insecticide is effective. Okay, so this is a good example, typical example. Third one. Okay, you can understand this third one problem very easily. Okay, you can write and submit in the Moodle platform. Okay.